Okay, now we have one-to-one and inverse. We see the inverse of the function. If you remember in calculus 1, we see the function has got the inverse if it's a one-to-one. And we find the graph. Why in the cal we see one-to-one, but here we mention both. It should be bisection. It should be one-to-one and onto. Then they have a inverse. Why? Because in the cal 1 we suggest that all functions are onto. Then we start the solving. But here no. Here we check the onto or not. Then that's why we need both of them. When you say one-to-one correspondence, means that bijection. Then if the function is bijection, then F inverse exists. Otherwise, we cannot say we have it. Clear, dears? Understood? Two things. So, if I want to check that function has inverse or not, I should check two things. First, shows one-to-one. Second, shows onto. Then we have an inverse. You say, yes, the inverse exists. Understood? Okay. So you can see from here, I'm not going to solve that one. It's easy. F of A, 2. F of B, 3. F of C, 1. So you see each one related to A2, B3, C1. Each one is related. So at the same time, onto. And at the same time is one-to-one, one-to-one, each one-to-one, each one-to-one. So yes, this function is invertible. We can say we can find the inverse. Okay, find the inverse. What do you mean by inverse? If I have that on direction is F, of course, the opposite direction should be what? It will be F inverse. Am I right? For example, if I call F inverse of 1 in this example, I is equal to what? To C. You got it, dear? F1 equal to C, so, sorry, Fc equal to 1, so F inverse of 1 equal to C. Let's see. Okay, here's going to Kirkuk, from the Kirkuk come back to here. This is F and F inverse by the same way, by the same function. And of course, this function is one-to-one and onto. Of course, we have an inverse, and here's the inverse. So how we find the inverse if the function is inverse, especially for the continuous functions? Because we solve for that one, we say equal to C. This is discrete. So if my question is like that, f from z to z, f of x is equal to x plus 1. So find f inverse if exists. Maybe it's not exist. Now I'm going to check one-to-one. Yes. Then check onto. Also yes. Now find, you can say, number 3 is bijective or is one-to-one correspondence. Yes. Now the number 4, I'm going to solve like that. Number 4, I say 4, 1. Make f to be y. What do you mean? You have f of x is equal to x plus 1. So make this f of x to be y. To be clear in your mind, to deal with it. Number 2, change or solve for what? For x. What do you mean by solve for x, Kaka? What do you mean by solve for x? Means that let x be in the left side and the other be in the right side. Okay, Kaka? So look, x equal to y minus 1. Now number 3, Kaka-jan, look at it. Change x to f inverse and you'll get it. You can say f inverse of, and of course, we change also and x to y or y to x. What do you mean by that? In calculus 1, in cal 1, we wrote like that. X equal to y minus 1. We change it to f inverse of x minus 1 is my inverse. But here, no. Here we just write like that. F inverse of y is equal to what? Y minus 1. The same. You can say f inverse for both sides, whatever you like. So I say f inverse of x is equal to f inverse of y. Understood, dear? The same strategy with the same things we got. The function from R to R is invertible or not? Yalla, quick. That function is invertible or not? They shall answer. They? No. Why? Because it's not one-to-one. It's not one-to-one. 2 and minus 2, the image is equal to what? 4. You got it, dears? That's why. Good. Now, you have many examples. I'll read that on Atom kindly. This is about here. Do you have any question? Dears, everything's clear? I think it's easy. Just need to prepare to read. That's it. Okay. We have a composition of the function. We say composite two functions together. Means that joining and make it to include together. For example, we are going to Hawler from here to Kirkuk, Kirkuk to Hawler, and going back together. Or maybe you can directly go to the Hawler by the, for example, airplane, like that. So we are going to from two places, A to B to C. A, that one is called, for example, G, and here is called F, or maybe direct F circle G. You got it? First G, second F, then from A to C is called, the function from A to C is called F circle G. And you saw many cases here, I think. So I'm going to solve the discrete example for you. Then we have another example, continuous example, and it will be done. I think it's easy for you, of course. Yalla. We have what? Just let me see. G of A, we have them, of course. We have a function. Okay, the function G. Let G be a function from the set ABC to itself. What do you mean by that? G is a function, look, from ABC to itself. So it means that also I have ABC. Am I right? This is the G. This is a function from here to there. And of course, GAB, GA is going to be B, GPC, GC is A. That's the given. I didn't say, I didn't define it. It's by default, it's by given. Okay. And, look at you. And every function from ABC to what? To 1, 2, 3. So again, from ABC, you can see also from here, to where? You can say AB, from B to C. This is then a function F. How? How define the elements here? Can you read? Okay. F of A on 1, 2, 3 here. 1, 2, 3. F of A equal to 3. B2, of course, C is 1. It's going to be related to 1. So now, okay, we just construct the graph or the diagram, the Venn diagram that they have. Now he say what? He say find F circle G of A. So how we find that one? F circle G of A. And how we answer this one? Look, at the beginning, if you remember, we have the box. We have a F box of something. Box of A. So this will be outside, that one be inside. You got it, dear? Kaka? Clear? Good. Then you can wash face if you like it. Then I'm going to check G of A equal to what? Equal to B. Or by given, you can see from G of A equal to B. Good. Now I'm going to check F of B equal to what? I don't know. F of B equal to 2. So I'll get 2. Look at here, F of B equal to 2. So the result is like that. How about G of I don't know, A. If I say G of, or F of G of C, go do it at home. It's easy, just loop by loop. Now another type of the question, we see that maybe continuous, and that's the diagram that we talk about. Maybe the example are continuous. We have F and G, and maybe I'm going to ask you 4 questions or 5, 6 questions. How? F is equal to 2x plus 3. And G equal to 3x plus 2. Am I right? Or maybe square root of 2. I don't know. Depends on the question. Whatever you like. So I say what? I say find F circle G of x generally. So how you solve? Kindly try to understand that one. You can answer all of them. Yalla. So how we answer that one? Yes. F, we put a G in the box. So what's the G? The function of G is like that, right? Now put that box inside of x instead of each x. What do you mean? So I'll get 2 box plus 3. What was the box? 3x plus 2. Then of course after that one multiply them. How about if I ask G circle F? Again I say is equal to G of F of x. Am I right? Then instead of G I have 3 plus 2. Put the box here, 2x plus 3. I think it's easy. How about G circle G? Right, G. So G is 2x plus, 3x plus 2. Okay. Again, 3x plus 2. You got it? Just multiply. Now, to be familiar with you, to be good at example, try to solve that one at home. It's easy. We have x squared. We have a square root. So find G circle F, F circle G, G, F, F, and all of them. Do you have any question? And there's one property that's very important that the composition will give us. If I have a function, if I composite with its inverse, I'll get the element. Understood? And vice versa is also true for the same things. I'll get y from other side and from that side. So I'll get the result. I'll get the identity element, just x. So try to use this example to your homework. Apply on homework. Which homework? That homework. I mean by example 25. Apply this one. We have a x squared and you have a square root of x. Do it. Check if you get x or not. Yalla. Question? Anything? Fine? Okay. Graph, we talk about graph, it's not important here. We talked before. But we have 2 important things for the computer students. 2 important. Of course, you are going to use it during your programming, I don't know, whatever you have. Okay, Kaka? Good. So now we have a floor and floor function, and of course, ceiling function. Ceiling function and floor function. The floor is like that, so kindly do not ask me during the exam, that one is floor or, okay, the symbol. Is that one or I don't know. You should know, you should control from here. And the ceiling is like that. What's the difference between them? What's the difference between them? That one, make it smaller. That one, make it larger. What do you mean by that one? Look. If I put, I'm going back to these examples, to the graphs. Look at this example kindly. It's easy. Yalla, you like it. I have between I'm talking about 1 over 2. I know 1 over 2 between 0 and 1. Am I right? So first of all, I forget something. This function, to symbolize it like that, floor function, is the function start from all real number, but the output is what? Integers number. How? If I put 1 over 2, I'll get 0. If I put 1 over, let me say 0.99, also I'll get 0. So if you see, we input everything. If I put 0, of course I'll get 0. So everything is included here. The output is what? 0, 0, 1, 1, 2, 1, 3, 4. How? If I say I'm 1 over 2 between 0 and 1, right? Any real number here, 0.9 is not here. 0.001 is not here. So between what? This 0.01 between 1 and 0. When I say between, I mean two integers. So when we talk about floor, we are going to choose the smallest one. We are going to 0. When I'm going to talk about ceiling, I'm going to what? To get 1. Understood? Good. So depending on this information, sorry.
It's approximation.
Exactly. Approximation, but to the greatest integer, to the integer. Exactly. So look at here. 1 over 2, by flooring, I'll get 0. By ceiling, I'll get 1. How about minus 1 over 2? Minus 1 over 2 is between 0 and minus 1, right? Here I am. So two smallest. Floor is going to where? Minus 1. How about the ceiling is going to 0 and the same. 3.13, 4, 7, 7. So integers number like that. This one in the mathematics is called step functions. Look, like a stair. We are going to up. Am I right? And how about here? Is also as the stair. You can go to the up, you can go to the down, whatever you like. What's that? Is the graph of graph, important, careful. The graph of the ceiling. Why? Because if I put any numbers between 0, I'll get 0. 1, I'll get 1. 0.5, it will be 0. If I put 1/2, I'll get 1. If I put 2/2, I get 2. If I put 2, 2. 3 point something, I'll get 3. Am I right? How about here? Minus 1.5. Minus 1.5 between 1 and minus 2, right? Kaka? Between minus 1 and minus 2. Because I'm talking about the floor, I'm going to the smallest one. So if I have a I will get what? Minus 2. You can see I have a minus 2 here. Not all, طبعا, just here. So that's how we graph them. I'm talking about ceiling, graphing of that one. How? I say I have what? If I put 0, I'll get 0. If I put 0.01, I'll get what? 1. So I'm here, I get 1. So that's why we will get 0 and 1. How about if I put 1, I'll get again 1. Sorry for here. Yalla. 1.1, 2. So I'm in 2. $1.12. How about 1.99? 0.99 again her 2, right? How about 2? 2 point something? 3 and go on. So 3 over y-axis. And come back to here, you will get the same. So this is the two graphs that they are important. And of course, we have many things to mention here. Forget about the table. These two examples, I'm going to solve that one for you, and that one will be homework. I think this is the last example. Okay? So this all proofs is not included for you. Actually, it was very important, but depending on the situation, I'm going to forget about that one till the end. You got it? till the end is not include. And kindly do not ask me during the exam that which one is include, which one is not include. You can watch the movies, videos, I mean. Okay. So this example is important, 29 and 30. We have what? Yalla dears. You can answer, of course. You can answer me. It's your duty. We have what? The data store. The data stored on a computer disk or transmitted over the data network are usually represented as string bytes. We have a bytes, okay. Each bytes, you know, contain what? 8 bits, right? We have 8 bits, 1, 0, 1, 0, 0, 1, something like that, okay. So how many bytes required to encode 100 bits of data? How many? How do you know? Sorry? We divide by 8. I will get what? But in that case, you should use the ceiling because 1 byte remains. If 1 byte remains, we are not going to throw it. We should put it in where? The new bytes, you know? If 1 bit, not 1 byte, if 1 bit remains, we should bring 1 byte and put it in one of them, right? So that's why we are going to use what? 13, not 12. Understood? You have a data. You are not going to delete your data, right? So instead of throwing, you'll bring it another one. For example, 3 digits are full, the rest 5 are empty. Did you get the idea? Understood? So that's all about today.